This is section 13.1, finding probabilities and odds. First, we have to go through some vocab so that you understand the kind of language that we're using in this section. An outcome is a possible result of any experiment. So anything that happens as a result of an experiment is an outcome. An event is also an outcome or a collection of outcomes. And the set of all your possible outcomes, anything that could possibly happen, is called the sample space. So the first thing you have to understand is how many possible outcomes are in a sample space. So we're going to look at this example where you flip a coin and roll a number cube or a dice. That's what they're talking about. And you're going to do one, you're going to flip a coin, and then you're going to roll a number cube. So you want to know what are the possible combinations that you can get when you do this. Or in other words, what are the outcomes in your sample space. So one thing you can do is draw this out in a tree diagram to find all the possible outcomes. So when you do a coin flip, you have two possible outcomes. You have heads or tails. But once you get the heads or tails, you're going to roll the cube. And when you roll the cube, you could get a 1, a 2, a 3, a 4, a 5, or 6, because there are 6 sides on the cube. So here we're going to have 12 possible outcomes. 6 when you roll heads first, and then 6 other outcomes when you roll tails first. You add them together, and you get 12 outcomes. Now, probability of event is the measure of the likelihood that it will occur. You want to know if it's going to happen. What are the chances that it's going to happen? Probability is always a number from 0 to 1, and you can express it as a decimal, a fraction, or a percent. There's a range of probabilities that let you know how likely something is to happen. So if you get the probability of 0, it's impossible that it would happen. If it's 25% or 0.25, it's unlikely. If it's 50%, it's equally likely to happen or not happen. If it's 75%, think of it as likely to happen. And if it's 1 or 100%, it would be certain. When you're thinking about these percentages, think of a weather forecast. If it says there's a 25% chance of rain, you know it's not very likely to happen. But if there's a 75% chance of rain, you know it is likely to happen. Now, theoretical probability can be calculated when all the outcomes are equally likely. Equally likely. So theoretical probability is always the number of favorable outcomes, the desired thing, the thing you want to happen, over the total number of possible outcomes. So in this example, you and your friend designed t-shirts with silkscreen emblems, and the emblems can be either gold or silver, and you've printed them in 2 colors, in red and green shirts. So you've got a box of shirts, and the number of shirts is shown in the chart. So you can look down and you can see the total of gold shirts would be 16 gold shirts, and the total with silver emblems would be 14. If you go across the rows, you see in green shirts we have 18 green shirts. 10 of them have gold emblems, 8 of them have silver emblems. And for the red shirts, 6 of them have gold emblems and 6 have silver emblems on them. Okay? So here's the question. What's the probability that a student, first of all, just chooses a red shirt? Okay? So he just walks up to the table and randomly he's going to choose a red shirt. Or he's blindfolded, he reaches into the box and he just grabs a shirt and it happens to be red. Well, think about the definition of probability. It's the favorable outcome, that would be to get a red shirt, divided by all the possible outcomes. That's all your shirts together. So the probability of red, and usually it's written like this with a P and then in parentheses what you're finding the probability of, would be the number of red shirts, because that's the good outcomes. That would be 12 shirts. And you would divide it by the total number of shirts, that's 30. To leave it in a fraction, you need to reduce it, so it would be 2/5. You could also convert it to a decimal if you'd want to. Now let's look at another one using that same data. What's the probability a student chooses a shirt with a gold emblem? Well, to choose a shirt with a gold emblem, gold would be the good outcome, the desired outcome. The number of gold shirts would be 16 because you're going to look straight down the gold column. And then you're going to divide it by the total number of outcomes, or the total number of shirts. You divide it by 30, so that would be 8/15. Now, experimental probability is different than theoretical probability. Experimental means you're actually going to do the experiment. You're going to do a number of trials and try to figure out what is the probability based on what you actually observe in the trials. So the number of trials is the number of times the experiment is performed. And each trial that has a favorable outcome is considered a success. So experimental probability is the number of successes divided by the number of trials. It sounds very similar to theoretical probability, except this time, instead of just calculating it, assuming that there's an equal probability something's going to happen, you're actually going to do the trial. So you're actually in science class doing an experiment. So here's an example. You spin a spinner 20 times, and this spinner is divided into 4 sections: red, blue, yellow, and green, and those sections are all equal. The results of your experiment are shown below. Does the experimental probability match the theoretical probability? Okay, so here are your results. You spun it 20 times. 5 times you got red, 9 times you got green, 3 times you got blue, and 3 times you got yellow. Well, first let's calculate the theoretical probability, and that's the desired outcome divided by all the outcomes. Okay? The theoretical probability would be 1 over 4, and it should be 1 over 4 for each one. For example, if you wanted to find the theoretical probability of red, red would be the desired outcome. That's 1 chance of getting red, and you would divide it by all the colors that are in the spinner. That would be 4. That's how we're getting 1/4. And the same would be for green, blue, or yellow. That's the theoretical probability. You have an equal chance of the spinner landing on each color. The problem is, you do the experiment, and that's not what happened at all. So the experimental probability is based on the actual results from the experiment. The probability of red is the 5 times it landed on there divided by the 20 total times you spun it. So it's 5 divided by 20, or 1/4. So that probability actually matches the theoretical probability. But look at the probability of green, blue, and yellow. For green, it's 9/20. For blue, it's 3/20, and for yellow, it's 3/20. So only the red probability matches the theoretical. Now think about what this means. It means there's something wrong with your spinner, because you know it should be 1/4. I mean, it could be a little bit off here and there, but it should be pretty darn close to that. When you're getting 9/20, that means something's wrong with your spinner. It's either bent, it's heavily weighted toward one, the sections aren't actually equal. Something is throwing it in favor of landing in green. Okay, this is the kind of thing people in Las Vegas look for when they're betting on things. Okay, you want the odds, actually, the probability to be in your favor for something rather than to be equal. Now here are odds. Okay, odds compare the favorable and unfavorable outcomes when all the outcomes are likely. Okay, favorable and unfavorable. Think what you were doing in probability. It was favorable over all outcomes. Now we're doing favorable versus unfavorable. So the odds in favor of something happening is favorable divided by unfavorable, and the odds against something happening is unfavorable divided by favorable. Usually we use odds in favor of something happening, although if you're betting a horse race, those odds are always the odds against something happen. The 7-1, the 5-3, those are the odds against. So kids get confused with that because it always looks backwards of what they expect it to be. So here's an example of finding odds. We're going to use that spinner with the 4 colors again, and we want to find the odds against stopping on green. Against stopping on green. Okay? So we're going to take unfavorable over favorable. If you're not stopping on green, you have a chance of getting 3 other colors. That would be the unfavorable outcome. And you're going to divide it by the one favorable, that is stopping on green. So you can write these odds as a fraction, like this, or you can write them as 2 numbers separated by a colon, 3:1, but it's always read 3, 2, 1. It's not read 3, okay? It's 3 to 1. right? So you have to get used to doing that when you do the odds.